Part 3, Ice Age Theory. The most important archaeological find in recent years was made in southeast Turkey. A circular temple was discovered called Göbekli Tepe and dated to the end of the Paleolithic period, that is 14,000 years before present. It was not regarded as a solar equinox and solstice observatory, although its construction indicates it was an astronomical observatory. National Geographic, June 2011. What were the builders of Göbekli Tepe measuring? They built numerous circular observatories. Why did they need so many? If the Göbekli Tepe builders were recording the time when a complete year had passed, as the Earth began slowing down on its orbital axis, based on one complete revolution of the planet on its orbital axis, as the Earth slowed down in transition to the Holocene interglacial, the number of extra days that had to be added onto the revolution to get alignment of a mountain peak with a star or constellation would be measured as an angle or portion of 360 degrees. The posts around the inside of the circular walls may represent those directions where yearly alignment occurred. 30 degrees would equal 30 days short of 360 degrees full circle rotation. Because of local difficulties and events that interfered with those people gathering to cut and move more stone pillars into place, some alignments were off and some observations were not made, that is, gaps in data. Observatory C, which was the first one excavated, represents about 23 years of recording. Overall, this effort enabled these people to predict animal migration times for hunts. According to my theory, the oldest solar equinox solstice observatories, that is, Göbekli Circle in eastern Germany and Gigantia Temple on Malta, were built 5,000 to 6,000 years ago, only after the Earth stopped rotating on its orbital axis.
Some of the temples built before 6,000 years ended up having to be realigned later on, preserved in their foundation kinks.
The precession of the equinoxes has a cycle of 25,776 years, quite different from the geological cycle of 21,600 years, and has been attributed to the rotation of the entire solar system. See Cruttenden, Precession Paradox in Forbidden Science, 2008. Rotation is opposite in direction for these two very different precession cycles. The zodiac rotates counterclockwise as the solar system rotates clockwise. The zodiac rotates clockwise as the Earth rotates counterclockwise on the orbital axis during an ice age. In Part 4 of my Ice Age theory, I will show the influence of our moon in creating 20 to 21 cycles of 5,140 years each within the 108,000 year Ice Age cycles, and how oceanic megatsunamis were created by rapid ice cap melting during and at the end of the Younger Dryas interval, recorded by the ancient Egyptians in the Book of the Dead, Descent of Osiris into the Underworld. I find it amazing that Egyptologists, geologists, and climatologists have missed this depiction of Osiris in descent as a scientific graph that was passed down to the ancient Egyptians from the first time, or Zep Tepi. I show a simplification of that graph without the mythological implications in this diagram, depicting how the Earth's precession decreased following the end of the last ice age, and where solar equinox solstice observatories were first built, and their relationship to the slowing down and stopping of the Earth rotating on its orbital axis. During interglacials, the Earth's rotation on its orbital axis slows down to 25,776 years. That is because the Earth's orbit is currently aligned with the sun's ecliptic and is off perfect alignment by only 0.01 degrees. Astronomy Today, 2014, Appendix 3, page A5, Table 3A. The Earth's rotation on its orbital axis, precession axis, is braked by the sun's north-south equatorial forces within the accretion disk. That braking of rotation perpendicular to the ecliptic allows clumping of fine matter to form planetoids and planets during the formation of our solar system. That is why there are 4 seasons in opposition between hemispheres during interglacial periods. That means the precession of the equinox, as measured today, is not constant, but cycles in length 4 times over a 259,200-year period, from 1 year during an ice age to 25,766 years in the middle of an interglacial, which is where we are today in our Holocene interglacial. However, during an ice age, the Earth's orbit is not aligned with the accretion disk, allowing the Earth to rotate freely on its orbital axis. Then the sun's gravity can pull on the Earth's mass eccentricity, or uneven mass distribution, causing it to rotate once on its orbital axis every year. That is because the Earth's mass, like that of the Moon, is not evenly distributed, and the Earth's core is closer to the South Pole than it is to the North Pole. The Northern Hemisphere contains most of the continents, and it's called the land world, while the Southern Hemisphere contains most of the oceans, and it's called the water world. The Earth's oceanic crust is much thinner than the continental crust, varying between 2 and 5 kilometers thick, while the continental crust varies between 40 kilometers and 70 kilometers thick, meaning that the Earth's core is on average further away from the surface in the northern hemisphere than it is in the southern hemisphere. In addition, the Earth is pear-shaped, with the southern hemisphere bulging more than the northern hemisphere because of the eccentric location of its core, which makes the southern hemisphere, the South Pole, want to point inside the Earth's orbit during an ice age. Because the solar axis, which determines night and day on Earth, is oriented 25.5 degrees from the orbital axis, which is vertical, it is not affected by the forces in the accretion disk, and its rotation within the accretion disk is not braked or slowed down. However, the orientation of the solar axis to the sun is controlled by how the South Pole is pulled closer to the sun by the increased mass of the southern hemisphere. That means the South Pole will preferentially point more towards the sun and be inside the Earth's orbit all the time during an ice age, while the North Pole will be outside the Earth's orbit, pointing further away from the sun. That is why the North Pole cap grew so enormously, while the South Pole cap vanished. Hapgood in 1955 speculated that the Earth's crust could slide, and Antarctica was 17 degrees further north to account for the warmer climate and loss of ice during the last ice age, which was primarily a northern hemisphere event. However, if the Earth turned on its orbital axis and the South Pole pointed towards the sun during a yearly orbit, Antarctica would be closer to the sun and be up to 17 degrees latitude closer to the sun. No crustal shift in latitude would be required as proposed by Hapgood, 1955. In other words, you do not need crustal slippage and actual physical movement of Antarctica closer to the equator. By the orientation of the solar axis pointing towards the sun, you would have those insolation requirements met. The sun would not set in Antarctica during an ice age. That landmass was called the Land of Punt by the ancient Egyptians, and they said that the sun never set on the Land of Punt.
Hancock, Fingerprints of the Gods, 1995. To proceed with this video, go to Part 4.